Question 5, and we've got an identity to prove here, which is that 1 plus cot squared x over cot x cosec x is equivalent to sec x, and we've got to prove that identity. Now I've started by drawing a line vertically down the page, just to remind me that I'm not allowed to multiply through or divide through. I've got to just stick with one side at a time, manipulate that in itself. I could manipulate the right hand side as well if I wanted to, independently of the left hand side, as long as they get to the same end point. Given that the left hand side is much more complicated, this is what I'm going to be focusing on with my rearranging. And there's a nice, the numerator straight away is quite nice. 1 plus cot squared x, hopefully that sounds vaguely familiar. That is part of an identity, which is 1 plus cot squared x equals cosec squared x. So that numerator can straight away be replaced with cosec squared x. Okay, and then we have a squared trig function, so cosec x all squared effectively, divided by cosec x. Well, that means a cosec x cancels, leaving us then with cosec x over cot x. Now, a bit of a glance at what we're aiming for. We're aiming for sec x. Sec x, remember, is 1 over cos x, and in fact we could write that in there, 1 over cos x, like that there. So now we're aiming to get this into the form 1 over cos x. So let's turn everything in terms of sines and coses and so on. So cosec x is defined to be 1 over sine x. Cot x is 1 over tan x, but it can also therefore be written as cos x over sine x, because tan is sine over cos. So if we're doing 1 over that, we can take the reciprocal of sine over cos and get cos over sine. Now if you divide in fractions, what do we do? Well, we flip and multiply, so 1 over cos x times by the flipped version of this, so sine x. Sorry, that was sine x there. My mistake. Sorry, that's 1 over sine x there. My mistake, 1 over sine x. Flipped version of this, sine x over cos x. Division by a sine x, multiplication by a sine x, they cancel out, leaving us simply with 1 over cos x. Okay, and that's where we finished on the right as well. So we've got left hand side equals right hand side. Okay, and hence we've proven the identity. Okay, question 5b. The question here is to solve an equation for bracket 1 plus cot squared x over cot x cosec x equals tan squared x plus 5. Now it was a hence question, so that tells you you're supposed to be using your answer from part A. The result from part A was this identity, 1 plus cot squared over cot cosec equals sec. Okay, and sure enough in here we've got 1 plus cot squared x over cot x cosec x. Okay, all of that then is just been multiplied by 4. So that is effectively multiplying sec by 4. So immediately our equation can reduce down to 4 sec x, I'll replace all of that with the sec x from part A, equals tan squared x plus 5. Okay, sec x we can't do much with, but tan squared, because it's a squared function, we can change that. And we can change that one using the identity 1 plus tan squared x equals sec squared x. Okay, so therefore tan squared x is equivalent to sec squared x minus 1. Okay, so substitute that into there, and we have 4 sec x equals sec squared x minus 1 plus 5. It's a quadratic, so let's get everything on the same side, keeping the squared function positive, so we're going to keep that there, move the 4 sec x across, so therefore the 4 sec x will become negative there. Minus 1 plus 5 is plus 4. And there we go. Okay, ask yourself the question, does that factorize? In fact, it does very nicely. It factorizes into sec x minus 2. Sec x minus 2. Minus 2 to the minus 2 is 4. Minus 2 sec x minus 2 sec x gives you the minus 4 sec x. So each bracket is exactly the same, and therefore we've just got simply sec x equals 2 from both of them. Okay, so no inverse sec button on the calculator, so we turn that into 1 over cos x. 1 over cos x equals 2. Take the reciprocal of both sides to make cos x the subject. So cos x equals a half. Inverse cos of a half. Now we need to be in radians because our domain here was 0 to 2 pi. So we're working in radians. Now my calculator currently is in radians from an earlier question. So inverse cos of a half, or 0.5, is 1/3 pi, a nice exact multiple of pi, which these calculators give us, so that's very nice. Okay, 1/3 pi, but we need to generate other alternatives, so a quick sketch of the cos curve, or use your cast diagram. Okay, so 1/3 pi in relation to a half pi. Well, 1/3 is less than a half, so that's about there then. Up, across, down. Okay, that distance there is a 1/3 pi, therefore that distance there is also a 1/3 pi. So 2 pi minus 1/3 pi. And that allows us to then state our final answer. So 1/3 pi, and then 2 minus a third, it's 5/3. So 1/3 pi and 5/3 pi.